Hello everyone, welcome to another video where we'll be discussing the numericals that may come in your 12th board exams. Alright, so this video is valid for CBSE and CHSE boards. So I hope it will help you. Okay. So in the previous video we discussed questions from capacitance. Okay, and we have discussed questions on electrostatics, potential. Now some questions we discussed from capacitance also in the previous video. So here I will be discussing questions from magnetism. Okay, we'll delve a bit into magnetism. So we will touch everything. It's not like I will keep focusing on one topic or one subject because very less time is left for your exam. So we should be touching everything. Okay. So these videos are numerical sessions. Basically, these numericals are not your standard normal. These are a bit standard numericals, like a bit higher. For example, if your question comes tough, you should be prepared to answer those questions. For that, you need a bit of those type of questions, which will test your concepts a bit, how strong you are, how strong your concepts are, and all, how clear fundamental you have. It depends on that. So for that, we need to prepare that way. If easy question comes, you can do it. No problem. I assume you can do it. But if question toughens up a bit, if it tricks you a bit, then you should be able to solve. So that way, we'll be solving some questions. All right. Yeah. It's not like it's too tough. It's just that a bit higher up. Okay. Okay. So first question. First question. Write down a bar magnet of length 8 centimeter and having a pole strength having a having a pole strength of 1 ampere meter is placed is placed vertically on a horizontal horizontal table with its south pole on the table. Its south pole. I want you to write the question with me. That will really help you. Don't think writing a question is a waste of time. Writing a question is not a waste of time. A neutral point, there is a purpose. This is a process. Writing a question, it imprints in your mind. Okay. If you just read the question and like, if you just read the question and do it, then see the answer is there, but you will slowly forget the question. Okay. A neutral point is found on the table at a distance of 6 centimeter north 6 centimeter north of the magnet. Calculate the Earth's horizontal magnetic field. Calculate the Earth's horizontal magnetic field. Calculate the Earth's horizontal magnetic field. A bar magnet of length 8 centimeter having a pole strength of 1 ampere meter is placed vertically in a horizontal table with its south pole on the table. A neutral point is found on the table at a distance of 6 centimeter north of the magnet. Read the question 2 times. The third time only you start to write the data. Okay? But read it 2 times with full concentration. Bar magnet of length 8 centimeter having a pole strength 1 ampere meter is placed vertically in a horizontal table with its south pole on the table. The neutral point is found on the table at a distance of 6 centimeter of the north of the magnet. Okay. Calculate the Earth's horizontal magnetic field. Okay, so I will draw the diagram for you at least. This is North Pole, South Pole, 2L. Okay, it's point P. BH. So this is for magnetic field to the South Pole, magnetic field to the North. Why is it like this? Because North Pole is here. So at this point it will be like going straight, no? And this is horizontal magnetic field BH. So what you are asked in the question? Calculate the Earth's horizontal magnetic field. That's what you are asked in the question. Bar magnet of length 8 centimeter and having a pole strength 1 ampere meter. Length length 2L is equal to 8 centimeter. Having a pole strength P, sorry, M, small m is equal to 1 ampere meter is placed vertically in a horizontal table. This is a horizontal table and it is placed vertically at a distance of 6 centimeter north of the magnet. Calculate the Earth's horizontal magnetic field. So this is the question. Try the question for 3 minutes. Then we will proceed. This is making an angle theta here. Okay, it's a straight line. Okay, I just could not. This the length is 2L. Hmm. So what is the question? Earth's horizontal magnetic field BH. You need to find. Hmm. First, what do you need to find? First, you need to find BN, BS. All right. Let's try to find BN and BS first. Hmm. Another thing is given in the question. Neutral point is found on the table at a distance of 6 centimeter from north of the magnet. Neutral point 6 centimeter north. So this actually is 6 centimeter. This P is your neutral point. Is that right? Neutral point. That means the net magnetic field at P is 0. Net magnetic field at P is 0. That means here BP you can say is 0. And it is 6 centimeter from north. So let's do what should we do? We'll do what? We will calculate all the magnetic fields at point P. And if we add them and make it to 0, we can get some. Right? Okay. BN. First tell me what is BS at point P. BS mu naught by 4 pi. Mu naught by 4 pi. Pole strength of the magnet is M. Right. So M by what is the distance? This distance is how much? This distance is D. Okay. It's not given. I'm just writing. It's D. So mu M by D square. This is BS. Hmm. This is ABS and this is along which direction? This is towards left. Okay. This is along PS direction. You can say PS. Okay. PS direction. P to. Next is a BN. Magnetic field due to north pole at point P. Mu naught by 4 pi M divided by what is the distance? 6 centimeter. But let's write it in in symbols. This is D. This is 2L. So this is the hypotenuse of this right angle triangle. This is 2L. This is D. So this will be D square plus 2L whole square root over. Isn't that right? So D square plus 2L whole square root over. Alright. D square plus 2L whole square root over. Alright. So that gives me mu naught by 4 pi. Sorry, root over square is there, right? Distance square, na? Sorry. Square. Yeah, mu naught by 4 pi M by D square plus 4L square. This is a BN. Okay. And the direction will be which direction? Direction will be NP. Why NP? Because for force For south pole, it will be towards south pole. For north pole, it will be away from north pole. Like in positive charge, the force should be away from positive charge. For negative charge, the electric field or force should be towards negative charge, like that. So Bn is equal to mu naught by 4 pi m by d square plus 4l square. Okay. Now we know BH. So okay, we know BP is a neutral point. So BH plus BN plus BS is equal to 0, isn't it? What do we need? We need BH. We need what? BH, which is the horizontal magnetic field. So what will I do now? This is 0. So BH is how much? BH is minus of, if I take the whole this to whole this side, BN plus BS. Yeah, isn't that right? Okay. Okay. There is another thing. Okay, wait. No. We can do in another way. That will be a better way. See, Bn is this much, right? We can we can do one thing. This is Bn, na? Bn is going down. It's like this. See, Bn. This is Bs. Okay. This is your theta angle here. So if we can write the this component of Bn, this will be what? Bn cos theta. So Bn cos theta is this direction, Bs is this direction. So their subtraction will be your Bh, isn't it? BH will be what? See, this is your Bn, this is your Bs, this is your theta. So this angle theta, this is the horizontal component for Bn. So Bn cos theta, right? Bn cos theta. So now Bn cos theta. So if I subtract Bn cos theta minus Bs, that will give me what? Bh. Okay? Yeah, isn't it? So what is your cos theta? You have to tell me what is cos theta. You have to tell me cos theta. Cos theta will be what? See, this is theta means this is your theta, right? This is theta. This is opposite angle. So cos theta will be base by hypotenuse. Base is your this d. Hypotenuse is your d square plus 4l square root over. Yeah. So cos theta is how much? So bn cos theta is bn into d by root over of d square plus 4l square. Bn is how much? Bn is again this one. So I will just put this in place of Bn. So that will be mu naught by 4 pi m divided by d square plus 4l square into d by root over of d square plus 4l square. Mu naught by 4 pi md by 3 by 2. Is that alright? Okay. Md by d square plus 4l square to the power 3 by 2. This is a bn cos theta. So bh is how much? Bn cos theta minus bs. So mu naught by 4 pi md by d square plus 4l square to the power 3 by 2 minus ds mu naught by 4 pi um, m by d square. Yeah, let's take the common. Yeah, Okay. So sorry for it. Bit of okay. So this would be what mu naught m by 4 pi d by this minus 1 by d square. Okay. Yeah. Now what do you have to do? You just have to put the values. That's it. Just have to put the values. So mu naught by 4 pi is 10 to the minus 7 into m. M is your what? Pole strength is your 1 ampere meter. So 1 ampere meter into d by d is your what distance? Distance is how much? 6 centimeter. 6 into 10 to the minus 2 divided by 6 centimeter, that is 0.06 square plus 4, sorry, 2l whole square. 2l is how much? 2l is 8 centimeter, so 8 square. 8 centimeters, 0.08 centimeter square. 3 by 2 minus 1 by d square, that is 0.06 square. Okay, this is now, you just have to solve this, you will get the answer. And if you solve it, you will get it as 22 microtesla. Okay, I have the answer for you. Okay, the next question is the question number 1. Question number 2. Question number 2. The Earth's magnetic field the Earth's magnetic field at geomagnetic poles has a magnitude has a magnitude 6.2 into 10 to the power minus 5 Tesla, find the magnitude find the magnitude and find the magnitude and the direction of the field. Find the magnitude and direction of the field. Find the magnitude and direction of the field at a point on the Earth's surface. On the Earth's surface, okay, where the radius where the radius makes an angle of 135 degree with the axis 135 degree with the axis of the of the Earth's assumed magnetic field. Of the Earth's assumed magnetic field. Earth's assumed magnetic dipole. What is the inclination at this point? What is the inclination at this point? Okay. Earth's magnetic field at geomagnetic poles has a magnitude this. Find the magnitude and the direction of the field at a point on the Earth's surface where the radius makes an angle of 135 degree with the axis of the Earth's assumed magnetic dipole. What is the inclination at this point? I'll draw the diagram for you. This 135 degree. Okay. Read the question two times. The Earth's magnetic field at geomagnetic poles has a magnitude of this. Find the magnitude and the direction of the field at a point on the Earth's surface where the radius makes an angle of 135 degree. Here, radius is making an angle of 135 degree with the axis of the Earth's assumed magnetic dipole. What is the inclination at this point? What is the inclination at this point? So try this question first. See, what is the formula for Earth's? So see here actually your Earth's field to like due to a dipole at the center. Okay, geomagnetic force. These are what? This will be Earth's what position it will be? It will be on end on position. Like it will be axial line, right? Okay, it will be your axial line, isn't it? So for axial line, we know what B is equal to mu naught by 4 pi 2m by r cube. Okay, mu naught by 4 pi 2m by r cube. Now there is another formula. Write down magnetic field. So this is your this one. Okay, you have to find the magnetic field at this point. So uh, okay, write down magnetic field due to a dipole. This is at r distance. The distance is r with an angle 135 degree. So this is a different kind of question. This is not your direct question. Due to dipole at a distance, we cannot just simply put this formula. Okay, at a distance r away from its center, has a magnitude has a magnitude b is equal to mu naught by 4 pi, okay, capital M divided by r cube 1 plus 3 cos square theta to the power half. Okay, mu naught by 4 pi capital M by R Q 1 plus 3 cos square theta to the power half. All right, and if you see, I can write it as half into mu naught by 4 pi 2m by R Q 1 plus 3 cos square theta to the power half. So if you see, this is your because of like end on position or an axial line. So I can write half b half. So this one I can write, right? This is your b, or let's write it as b naught. So half b naught 1 plus 3 cos square theta to the power half. All right. Hmm. Now what is b naught? Earth's magnetic field at geomagnetic poles has a magnitude. Okay. See again, I will explain geomagnetic poles. This is your Earth. Geomagnetic poles. Your Earth's magnet is kind of like this, isn't it? So the geomagnetic poles, these are which kind of positions for a magnet? This is a magnet. These are which positions of a magnet? If this is the axis, these are axial points. That's what I was saying. These are axial points. Okay. If it was here, it would have been equatorial point, but these are axial points. So I wrote this as the axial magnetic field. Okay. So for Earth, this is B naught. B naught is your axial point, and it is given how much? 6.2 into 10 to the minus 5. So half into 6.2 into 10 to the power minus 5 into 1 plus 3 cos square 135 degree, isn't it? 135 degree half to the power half. Cos 135 is equal to cos 35, or sorry, cos 45 or sin 45, whatever. So this becomes 3.1 10 to the minus 5 1 plus 3. Okay, cos 135 is minus 1 by root 2 square 3.1 10 to the minus 5 1 plus 3 by 2 half. Okay, 3.1 and 10 to the minus 5. This becomes what? 5 by 2 into the half. Okay, so if you have to calculate this one, and after calculation, you will get 4.9 into 10 to the minus 5 Tesla. Okay, hmm. 4.9 10 to the minus 5 Tesla. This was the question. I think. No, what is the okay? What is the inclination at this point? Inclination is your alpha. This is the inclination. Okay, so angle of inclination alpha. How will you write it? Hmm? See right on angle alpha of the field with the vertical is formula for it is with vertical is tan alpha is equal to tan theta by 2. Okay, tan theta is how much? Theta is 135. Tan 135 is minus 1 by 2, so this is minus 0.5. So tan alpha is equal to minus 0.5. So alpha is equal to what? Angle of inclination is, you can just write tan inverse minus 0.5. Okay, no need to do because we don't know the value, so you can just write it. So this is your form answer, right? And this is the magnetic field. This is the magnetic field, and that is the angle of inclination. All right. Is that all right? I hope you understood. Okay. Very good question. Thought provoking question. Number three. Number three. Magnetic needle. Magnetic needle free to free to rotate in a fixed vertical plane, free to rotate in a fixed vertical plane, in a stays in a direction making an angle of 60 degree, making an angle of 60 degree with the horizontal, making an angle of 60 degree with the horizontal. Okay. If the deep at this place, if the angle of deep, if the deep at this place is 137 degree, 37 degree, find the find the angle of the find the angle of the fixed vertical plane, fixed angle of the fixed vertical plane with the meridian, with the meridian. Okay, a magnetic needle free to rotate in a fixed vertical plane stays in a direction making an angle of 60 degree with the horizontal. If the deep at this place is 37 degree, find the angle uh, find the angle of the fixed vertical plane with the meridian. Okay, magnetic needle is there. It's free to rotate in a fixed vertical plane, stays in a direction making an angle 60 degree with the horizontal. 60 degree with the horizontal. If the deep at this place is 30, deep angle of deep is delta, 37 degree. Okay. Find the angle of the fixed vertical plane with the meridian. So tan delta is given. Okay. Delta is given. Hmm. Okay. So see, if the vertical plane, the vertical plane makes an angle theta with the meridian. Okay, makes an angle theta with the meridian. The horizontal component of the arc speed will be how much? The horizontal component will be how much? BH cos theta. It's making an angle theta with the horizontal. This is your B. So this will be your BH cos theta, isn't it? Yeah, horizontal BH cos theta. So BH cos theta. So the angle of DP is delta is 37 degree. So the angle, write down formula, the angle between the needle in equilibrium, between the needle in equilibrium second, and the horizontal will be given by tan delta L is equal to BV by BH cos theta. Is the formula. Okay, V by BH cos theta, which is actually equal to tan delta divided by cos theta. How? Because BV by BH is your tan delta. Okay. So tan delta by tan delta is our tan 37 degree. And your theta, what is theta here? Theta is what we need. Tan delta L, the angle that is making with the needle thing, 60 degree. Okay, the needle free to rotate in a vertical plane stays in direction making an angle 60. So this is your delta L. Okay, so tan 60 degree. So your cos theta is what we need. Cos theta because angle of the fixed vertical plane with the meridian. That means your theta. So cos theta is equal to tan 37 degree divided by tan 60 degree. Tan 37 degree, remember 3 by 4. Okay. Tan 37 you remember is 3 by 4. So this becomes root 3 by 4. Okay. So theta is equal to cos inverse root 3 by 4. Don't write it as 30 degree. 30 is root 3 by 2. Okay. Alright. Next question. Question 3 it was. Question 4. A moving coil galvanometer. A moving coil galvanometer has 100 turns and each turn each turn has an area each turn has an area 2 centimeters square. The magnetic field the magnetic field produced produced by the magnet is 0.01 Tesla. The deflection in the deflection in the coil the deflection in the coil is 0.05 radian when a current of when a current of 10 milliampere is passed through it is passed through it. Okay. Find the torsional constant. Find the torsional constant of the suspension wire. Okay. Find the torsional constant of the suspension wire. Moving coil galvanometer has 100 turns and each turn has an area of 2 centimeters. The magnetic field produced by the magnet is this. It's a straightforward question. You just need to remember the formula. The deflection in the coil is 0.05 radian when a current of 10 milliampere is passed through it. Find the torsional constant of the suspension wire. Okay. So the formula for it is torsional constant you are asked. That means K. K is the torsional constant. Okay. K is formula is how much? DINA by theta. So by theta. Okay. So we have everything here. 0.01 Tesla current is there. How much? 10 milliampere turns 100. Area is there 2 centimeter 2 into 10 minus 4 meters square. Divided by theta is your 0.05 radian. So everything is there. You just have to get the value. So it's just a formula question, formula based question, but you need to remove the formula for that. Okay. Next question. Next is a good question. Number 5. Galvanometer has a galvanometer. Galvanometer has a a resistance of 100 ohm. Okay, when a current passes, when a current passes through the galvanometer, when the current passes through the galvanometer, okay, 1% of the current, 1% of the current goes through the coil, goes through the coil. 1% of the current goes through the coil, and the rest through the shunt. The rest goes through the shunt. Find the resistance of the shunt. Find the resistance of the shunt. Galvanometer has a resistance of 100 ohm. Okay. When a current passes through the galvanometer, 1% of the current goes through the coil, the rest through the shunt. Find the resistance of the shunt. Right. See, this is a galvanometer, and parallel to the galvanometer is your shunt resistance RS. What is and the galvanometer resistance is 100 ohm. Okay. When a current passes through the galvanometer, passes through the galvanometer, when the current passes through the galvanometer, 1% of the galvanometer goes through the coil, the rest through the shunt. That means 1%, 1 by 100 goes through this one. For example, total I is coming here. It will be divided, of course, because this is a parallel connection. It will be divided. In series, it is not divided. In parallel, it will be divided at this junction. So 1 by 100 of the current is going through the galvanometer, that's through the coil. And what is the rest? Rest through the sun. Rest means what? 1 minus 1, 100. That is 99 by 100, 99%. So 99 by 100 is going through resist RS. And they are mixing up, they are meeting up again here and giving I. So this is what it is. So but okay. So find the resistance of the sun. RS we are asked. So see one thing here how to solve this. These two, like this one and this one, they are in parallel connection, right? If this is A, point B, see these are connected to the same terminals. This is connected to A here, to B. This is also to A, this to B. So these are parallel connection. So parallel connection means what? Potential will be same. So V across G will be V across shunt, isn't it? So V across G is how much? I into R. I is how much? 1 by 100 into I into R. R of G, galvanometer, is equal to 99 by 100 into I. Current into resistance. Resistance through shunt is RS. Yeah. Okay. Now you can see 100 cancelled out. I cancelled out. RG. RG is how much? Resistance of galvanometer is 100 ohm. So 100 ohm is equal to 99 into RS. So RS is how much? RS is 100 by 99 ohm. Okay. 100 by 99. That will be the answer. Is it alright? Is it clear? Is it clear? Yeah, it's a very good question. So this your concept of galvanometer and shunt will be clear. Next question, question number 6. Okay. You know, the question. Bar magnet, mass 100 gram, length 7 centimeter, width 1 centimeter, and height 0.5 centimeter. Takes 5/2 seconds to complete an oscillation in an oscillation magnetometer placed in a horizontal magnetic field placed in a horizontal magnetic field of 25 microtesla. Find the magnetic moment of the magnet. Option B. If the magnet is put in the magnetometer with its 0.5 centimeter edge horizontal. What would be the time period? What would be the time period? Okay. Bar magnet of mass 100 gram, length 7 centimeter, width 1 centimeter, height 0.5 centimeter, takes 5/2 seconds to complete an oscillation in an oscillation magnetometer placed in a horizontal magnetic field of 25 microtesla. Find the magnetic moment of the magnet. If the magnet is put in the magnetometer with its 0.5 centimeter edge horizontal, what would be the time period? Alright, this is the question. So, if you see, read the question twice, okay, then try to solve only. I assume you have read the question twice, you pause the video, read it, write the question first, okay. So, momentum inertia, Mi of the magnet, above the axis of rotation is how much? What is asked in the question first? What will be the time period? Okay, time period. Hmm. Time period you are asked, and here it's completing an oscillation and oscillator magnetometer. Okay, so for time period formula is T is equal to 2 pi root over of I by mb for this oscillation magnetometer. Okay, I by mb, sorry, I by mb, where m is your magnetic moment, b is your magnetic field. First of all, we need to find I. So I is equal to how much? It's m by mass. This is m mass. It's m dash one. M by 12 L square plus B square. Okay, L square plus B square. So length and breadth are given. Length and width, that means breadth, they are given here in this question. So M dash as in mass is 100 10 to the minus 3 because 100 gram divided by 12. L square is 7 in 10 to the minus 2 square, whereas 1 into 10 minus 2 square. Okay, yeah, and this you will get I from here. Okay, then what you do? T is equal to 2 pi I by m b. I have written it. 2 pi I by m b. So what do we need from here? The first case, find the magnetic moment of the magnet. So magnetic moment, easily we can calculate m. So everything, let's take to that side, t by 2 pi. This root over will become square I by mb. So I is equal to how much? mb t by 2 pi whole square. Okay, t by 2 pi whole square. So just have to, uh, okay, we need m na, sorry. We need m. M is equal to 4 pi square by t square. This goes to this side. I by b. So just put all the values 4 pi square. Okay. I is equal to how much? I you just got from here. Na? Whatever you got I here, you just put it here. You got a magnetic field. Magnetic field is how much? It's given, right? Magnetic field 25 microtesla. 25 and 21 minus 6. And your time period square. Time period is how much? Hmm? Time period must be given in the question. It takes pi by 2 seconds to complete an oscillation. That in itself is time period. Pi by 2 seconds to complete an oscillation. This is an oscillation. Take pi by 2 seconds to complete. That means that is a time period. The time taken to complete one rotation is a time period. So pi by 2 seconds. That means 3.14 by 2 square. T square. So if you calculate it, so 3.14 square, 3.14 square, 1 square will be cancelled out. If you calculate, you will get the answer as 27 ampere meters. Now, what is the question? Next question. If the magnet is put in the magnetometer with its 0.5 centimeter edge horizontal, what will be the time period? Okay. So here, edge is horizontal. This is a what? 0.5 centimeter is now what? Edge. Edge means what? Here 0.5 centimeter is your breadth. Right, but the length remains the same, 7 centimeter. So here I dash will be again m dash by 12 L square L dash square plus B dash. Okay, m dash is how much? Whatever it is. Okay, you just put 100 and 10 to the minus 3 whatever. L dash square. L dash is how much? L is as usual 7 10 to the minus 2 square into B 0.5 minus 2. This is I dash. Okay, I dash. But we need what? We need your time period. Time period now. We need the change time period. So we can say T dash is equal to what? 2 pi root over of I dash by NB. If you can, because these two will remain same. So if we can compare these two, T dash by T, that is root over of I dash by I only. Because MB will be cancelled out. So whatever I dash you will get here, and whatever you got there, you just divide. And T is what? The original T is your pi by 2 seconds, isn't it? So you just multiply pi by 2 here, you will get the T. I hope you got it. Okay, that is the way to solve this question. Alright, I hope you understood. Okay, write some questions for homework. Question number 6, I think, or something. Can there theoretical questions? Can the Earth Can the Earth's magnetic field be vertical at a place? What will happen to a freely suspended magnet at such a place? What is the value of D here? Value of D here. Okay, next question. Can can the deep at a place be 0 and 90 degree? 0 A 0 B 90 degree. Okay. Question number 8. Compare the direction of the magnetic field. Direction of the magnetic field inside a solenoid. Inside a solenoid with that of the field. With that of the field. There, if the solenoid is if the solenoid is replaced by its equivalent combination of north pole and south pole. Okay? Combination of north pole and south pole. Is that alright? Okay. These are some homeworks you should try at home. Okay. And please write the questions and then try to solve. Okay. Don't just copy paste the answer. Okay. It won't be that beneficial. Alright. Any doubts you can let me know in the comments. Alright. Yeah. So that'll be it for this video. We will be solving more questions in upcoming sessions from all the chapters. So stay tuned to the channel and it will be really helpful in your preparation. Thank you very much.